For this test current and voltage coding, we first define the current sensor and voltage sensor pin, which the output will be given to D34 and D35 in ESP32, the not MCU. And then first we see the current measurement for IRMS, and then we declare the variable, and then the model. Okay, we select model as 0 because the sensitivity is 0.185 for the current sensor we are using now is 5 ampere module. And then for this voltage measurement, we declare the variable also. And then inside this coding, we set up the serial monitor as 115200, this one. Okay, and then first we read the current from current sensor. So we first will measure the raw voltage, and then we get the analog read from current sensor and divide by 4095. This is the analog level that the ESP32 has, and then we times with the 3.3 input voltage. After that, we minus off 1.390, and then this is actually the offset value when there's no current. You can see from here, because now I haven't turned on my bulb, and then from here we can see the B current sensor roughly about 1.388, and then 1.40, 1.91, 1.8380. So I get the rough value, average value roughly about 1.390. So we minus off the offset, and then it will give the IRMS nearly to 0 ampere. Okay, but this one roughly 0.012, 0.053 lah. So it's still fluctuated. Okay, after that we get the current value as a positive value. So I use the absolute function for float, and then we print it out in the serial monitor as this. Okay, so we let it auto scroll. Okay, after that we read the voltage. So the voltage I get from this ZMPP101B is actually a sine wave. So to get the VRMS, okay, first as for this coding, right, we analog read the voltage sensor, and then we use this 2046 to get the positive value because the sine wave, and then it is actually half of the 4095. So we take the positive part of the sine wave, and then whichever the value is higher than 2046, and then it will be put into the array. The positive value will be put into the array. And then how about the negative part? We set the negative value as 0 into the array. So in the array will be the positive value, and also many 0 value lah. After that, we use this for loop function, the for loop function, to find out inside the array the highest value. We set it as VPeak. So the VPeak, after that because this is the uncalibrated value yet, so we get the VPeak, and then we divide by square root 2. We divide by square root 2 to get the VRMS from VPeak. After that, we calibrate the data. For example, as you can see, this one uncalibrated VRMS is roughly 1663. Okay, 1663. So just now when I do my coding, it fluctuated at 1680. That's why just now I used 1680, and then divide by the voltage measure from the multimeter, which is 244, according to the measurement just now. And then these two values divide, will get 6.885. So the VRMS calibrated will be divided into 6.855. So later we will get the voltage if I turn on my bulb around 244. Okay, so we print the uncalibrated RMS and the real after calibration RMS, VRMS. So okay, from now we can see the VRMS as 0, this one, and then the IRMS as 0.031 ampere. So now I will turn on my bulb. Okay, I let it auto scroll, and then we can see that this IRMS started to increase, like 0.812, 0.2, 0.2. Okay, as I scroll below, and then it will like become smaller and become bigger again, so it will fluctuated, but then averagely we will get 0.2 something or 0.3 something. So it, according to the theory part, like the 70 watt, and then with the voltage 230, roughly we'll get 0.3 ampere in theory lah. Okay, so for this VRMS also, we can get 24 something, 241, and then the 0.1 is ampere. So to get the power consumed by the bulb, actually we just use this IRMS times with VRMS, then we can get a bulb power consumption, and also we later we will calculate the energy usage also by using these two values. Okay, so when I turn off my bulb, okay, we can immediately see that the current value become 0.0 something, which nearly to 0 ampere, and also the VRMS straight away become 0.0 volt. Yeah, that's all from me, Ching In, for this test current and voltage coding. Thank you.